I'm John Simmel. I'm a first-year engineering physics major, and I specialize in finalizing all the lab documents for the team for the AEV project.
Hi, I'm Josh Abraham, a first-year aerospace engineering major, and I worked on the Arduino code for the AEV project.
Hi, I'm Alex Labman, I'm first-year undecided engineering major, and I worked on the SolidWorks documents for the AEV project.
Hello, I'm Yingchen Wang. I'm second year in computer science engineering, and I'm specialized in making sure that all the procedures were followed by the AEV project. Initial design, I use the shape of a starship, and so that can reduce the air friction a little bit. But since in that case I need more material on those, so the mass will be increased a lot. So we didn't choose that for the final design.
Initial AEV concept design, I used a triangle-shaped base so that the Arduino board and the support arm could fit, with the propellers off to the side so they would not get in the way.
My initial AEV concept was constructed around a T-shaped body with wings and propellers placed on the front. The design's biggest drawback was that it would be very hard to modify, as a lot of components overlap in the front where the wings are. The wings were angled up just to be creative. I wanted to see if that would have an interesting effect on the performance of the AEV.
My initial AEV concept design, I used a long, narrow piece for the base, which had enough room for the Arduino board on top and the battery on the bottom. Along with that, it let two wings be on each side of the base with propellers attached to each side, which allowed for optimal speed and efficiency, which is why it was chosen for the final design. The objective of the AEV was that it must start at the distribution center. After that, it must travel to the warehouse entrance gates. At that point, when it reaches a gate, it must wait for 7 seconds to receive approval to enter. After that, it will travel to the loading dock for a supply pickup. It will stop at the loading dock and attach to the caboose. At this point, it will travel back to the facility's entrance gate and stop to have the cargo checked and approved, which will take approximately 7 seconds. And lastly, it will travel back to the distribution center where the supplies will be distributed to the consumer.
In our original code, we relied too much on coasting, which gave us inconsistent results. So we added in reverse when we approached the gate so that we would limit the amount of coasting we did and we would achieve more consistent results.
Performance test, we use just the initial design for the first design. And later on we come up with the second design. And that one is much better than the first one. And so we move forward with that one for the final test. And the second design is much smaller than the one before. Also, we moved the propeller leader on the bottom, and also we replaced the battery for the balance.
For the final design, the team chose to move forward with our second prototype, as it outperformed the first prototype significantly. The rectangular parts of the AEV were switched out for similar parts of lesser size to decrease the mass of the vehicle and increase speed and efficiency without having to alter the Arduino code portion of the design. A metal bracket was added to the front and spaced to account for the caboose the AEV needed to retrieve. It was spaced out because early versions of the bracket were too close to the AEV, so the propeller blade would actually end up hitting the bottom of the caboose. Overall, the team's final design was constructed with the idea that it should be simple and small as to best facilitate testing procedures, maintenance, and efficiency.
On the day for final testing, the team ran into a lot of problems with the AEV's performance. The program that had worked perfectly before suddenly did not. This could be attributed to the differences in the tracks between the classrooms or quality of the batteries, but regardless, the team did its best to account for these factors. The AEV made its way around the track performing all the required tasks, only failing in how far it traveled during certain portions. The team scored a 44 out of 50 for final testing.
I learned about the screening and scoring concept and how that can be used to take different people's ideas and to incorporate all the good ones together to make a final design. Also, the different commands used in the Arduino script and what exactly they do and how they can be used together. And lastly, individual lab reports are much worse than
For me, the biggest obstacle